So it's now time to build our model properly, so that we can show the price and output at which the firm is going to maximise profits in monopolistic competition. So to do that, we need to analyse firstly closely the relationship between marginal revenue and average revenue. What we showed in the last video is that when the firm cuts price, average revenue obviously falls, but marginal revenue falls by more. And the reason is that you can't just cut the price for the extra units, the marginal ones, you have to cut the price for all of the units. And therefore, marginal revenue falls much faster than average revenue. Now we can show that there are also links to elasticity that we'll show in a minute. So let's construct a simple demand curve. So here we'll have price. 11, 10, 9, 8, 7, 6, 5, 4, 3, and so on. And we'll say, let's suppose that quantity goes 0, 1, 2, 3, 4, 5, 6, 7, 8. It's a pretty straightforward downward sloping demand line. We know that average revenue is equal to price. If we sell all our units at £8, then that's the price. Then on average we get £8. So let's have a look at total revenue. Total revenue is just price times quantity. So 0 times 11 is 0. 10 times 1 is 10. 18. 3 times 8 is 24. 4 times 7 is 28. 6 times 5 is 30. 5 times 6 is 30. Clever that. 4 7 is 28. And 3 8 is 24. So now let's have a look at marginal revenue. So for the first unit, we go from 0 to 10. It's 10. For the second unit, 10 to 18, it's 8. Then 6. Then 4, 2, 0, minus 2, and minus 4. Well, that's all very interesting. So, firstly, what's the relationship? And what we can see, is that every time average revenue falls by 1, minus 1, minus 1, minus 1, minus 1, marginal revenue falls by 2. And this is always true. And you can prove this mathematically, which I'll do in a separate video for people who really like that type of thing. But it's always true. When average revenue falls by 1, marginal revenue falls by 2. So the second thing that we can see is, if you think about what's going on here, what's going on down here? What's going on is that when we cut the price here from 5 to 4 and 4 to 3, we have negative marginal revenue. What's negative marginal revenue? All negative marginal revenue means is that total revenue is going down. So why is total revenue going down? This has nothing to do with profit. There's no costs here. So what's going on? Well, the answer is, we know from last year that eventually if you cut price too far, total revenue falls because demand becomes inelastic. Here, if we cut price from £4 to £3, that's a 25% decrease in price. What's happened to our quantity? It's gone from 7 to 8. A seventh, what's that, about 14%? Demand's risen by about 14%. Demand's inelastic. So when we cut price, total revenue goes down. Whereas up here, when we cut price, total revenue goes up. Because if we cut price from 10 to 9, that's a 10% decrease in price. But demand has doubled from 1 to 2. That's a plus 100% increase in demand. So there's nothing surprising here, and indeed we just did it last year. Last year we said on the top part of the demand line, PD is greater than 1. PD is minus 1 to minus infinity. So a cut in price leads to an increase in total revenue. Down at the bottom, we know that PD is 0 to minus 1. It's inelastic, so when we cut price, total revenue goes down. And you can check that back in one of the videos on elasticity when we first did it. So elasticity is relevant here. When we cut price and total revenue goes up, demand is price elastic. When we cut price and total revenue goes down, in other words, marginal revenue is negative, then demand is price inelastic. So let's put all that together now and see what we can now see. What's that showing us? So we've got our demand line, that slopes down like that, and we said that that is also the average revenue line. We said that at a quantity of 1, in our example, that was £10. So marginal revenue and average revenue were initially the same. What we then said is that marginal revenue, every time average revenue went down by 1, marginal revenue went down by 2. And what that means is that MR is twice as steep as AR. So it cuts halfway between there and there, which it might or might not do on my diagram here, but you can always just put in those little signs to show that it's equal. So that's our relationship now. When we cut price, obviously average revenue falls, but marginal revenue falls by faster, because by more, because we have to cut the price of all of our units. We also said that we can show the link with total revenue. We said that that is the midpoint of the demand line because it cuts halfway. And we said we know from last year that here PED is -1 to -infinity, and here PED is 0 to -1. So we can also say, therefore, if we call that Q1, up until that point, marginal revenue is positive. When we cut price, demand is elastic, so total revenue goes up. After that point, demand is inelastic. Therefore, if you cut price and move along there, total revenue goes down. Therefore, as we increase output, total revenue rises up until that point. Obviously, to start with, here, you're not selling any units. Here, price is 0, you're giving it away for free. If you're giving it away for free, you won't have any revenue either, so total revenue will fall. So therefore, that's total revenue. There's nothing to do with costs here, it's all to do with elasticity. When we cut price, initially, total revenue goes up because demand is elastic. Eventually, demand becomes inelastic, and when we cut price, total revenue goes down. But the key point here, is that MR is 2 times as steep. Is 2 times as steep as AR, and that will always be true. And you can prove that using calculus if you're really very, very interested in that, which I'll do in a separate video, which if you hate maths, you don't have to watch. One other thing that you can show, just for the last thing, is where is total revenue maximised? We said that as long as we're moving along this bit, demand is price elastic, so total revenue is going up. As soon as we get past the midpoint and demand becomes inelastic, if we cut price now, total revenue goes down. Therefore, when marginal revenue is 0, total revenue is maximised. So up to that point, total revenue is rising. After that point, total revenue is falling, so it's maximised at that point. So at the midpoint of the demand line, we know that total revenue is maximised, we know that marginal revenue is 0, and we know that price elastic demand is equal to -1. And again, that bit about PED being equal to -1, you can prove mathematically, should you so desire.